Okay, Assalamu warahmatullah. In this video, we will start solving exercises about the chemical bond. In the first exercise, choose the correct answer. The number of valence electron in sulfur 16 is. In order to determine the valence electron, we must write the electron configuration. The electron configuration of sulfur is K2L8 M6, so the valence electron is 6. The correct answer is C. The valence of atom, whose electron configuration, valence of atom, and how much the atom need or lose or gain in order to become stable. Since it is and with L5, it has 5 valence electrons in order to become stable, so it needs 3 electrons to become stable. Need 3 electrons to become stable, so the valence electron or the valence of this element or this atom is 3. You then need 3 electrons to be stable. Octet rule. The valence of atom or the valency is the definition or the meaning of valence of atom is the number of paired electron of the paired electron or the lone pair, or is the number of single dot electron in Lewis dot symbol, or the total number of electrons. The valence of atom according to Lewis dot symbol, it represents the number of single dot electron. For example, if we have an atom X with the following single dot electrons, so the valence of this atom is equal to 3. If an atom A with following Lewis dot symbol, it has 2 single dot electrons, so the valence is equal to 2. The type of bond that results from sharing is a sharing of a pair of electron. One pair of electron, it represents a single covalent bond. Ionic bond is formed between metal and non-metal, so the correct answer is C. The type of bond represented in the adjacent figure is, since we have a sharing of one pair of electron between phosphorus and bromine, we have a single sharing of one electron. We have share of one electron, so it is a single covalent bond. In the second exercise, given the following elements or atoms, Al with Z equal 13 and sulfur with atomic number is equal to 16, write the electron configuration of each atom. As we studied before, the number of to write the electron configuration of each atom, we start by writing in a neutral atom number of electrons equal number of protons is equal to the atomic number Z. So for aluminium, the electron configuration is K2L8M3, which is equal to 13 electron, and for the sulfur, which of 16, K2L8M6. To write the Lewis dot symbol of each atom, it represents the number of valence electron. So aluminium has 3 valence electrons, 1, 2, and 3. Sulfur has 6 valence electrons, so the sulfur has 1, 2, 3, 4, 5, and 6 electrons in the Lewis dot symbol. Part C indicates the valency of each atom. Valency, how much element will become stable. Since aluminium has 3 valence electron, so it loses 3 electrons to attain stability. So valency is equal to 3, or we can refer to the lowest dot symbol. It represents also the single dot electron. According to sulfur, which has a lowest dot symbol 1, 2, 3, 4, 5, and 6, since it has 2 single dot electrons, so the valency is equal to 2. Identify, we need to explain the type of bond, how the bond is formed in aluminum sulfide between aluminum and sulfur. Since we rewrite it, since Al has 3 valence electron, any element has 3 valence electron, it loses 3 electrons to attain stable octet rule. And since it loses electrons, so aluminum will form Al3 plus ion. Then it forms a positive ion, Al3 plus ion. Since sulfur has a 6 valence electron, any element with 6 valence electron, it gain is an if aluminum lose, the other element will gain 2 electrons coming to attain stable octet rule. And form a sulfide ion. When an element form a gain electron, so it form an anion and form as 2 minus ion. So we have a negative ion and a positive ion. Therefore, the type of bond formed is ionic bond between 2 opposite ions, and we write its definition, which is electrostatic force of attraction. And we write the definition of ionic bond: electrostatic force of attraction formed between opposite ions. هن Al3 plus ion and the sulfide ion S2 minus. In order to write the formula unit of sulfide ions, we have Al3 plus is ion and we have sulfide ion. By using a criss-cross method or to balance the charges, 3 is written below as a subscript for S and 2 for aluminium. So the formula unit is Al2 S3. In order to balance the charges, we can also, in order 3 plus to become balanced to 2 minus, we multiplied it by 2 and sulfide ion multiplied by 3 in order to have a total charge 6 plus. If we multiply the charge, and we have 6 plus, if we multiply the charges, we have 6 minus, so they are balanced. So the formula unit of aluminum sulfide is Al2S3. For the third exercise, we have an adjacent rectangle represents the phosphorus bromide. Specify, we need to explain how bromine and phosphorus attain stability, how each bromine and phosphorus become stable. As we notice here, every bromine share 1 electron. Every bromine share 1 electron with phosphorus atom. So each Br atom share 1 electron with phosphorus atom, and also P phosphorus atom also can share 1 electron, and P atom also share 1 electron with each bromine atom. Then the bond is a single covalent bond. Then, according to the figure, each Br atom and phosphorus atom share one electron with each other in order to become stable or attain stable octet. Deduce the type of bond. Since we have sharing of one electron, we have sharing of one electron, then the bond is single covalent bond. Then any bond results from sharing of one electron, so we have a single covalent bond. Write the lowest dot symbol of Br. According to the figure, Br has this is the lowest dot symbol of Br. We have 3 lone pair and a single electron that is shared with phosphorus. Phosphorus has 2 lone pair here, has a lone pair of electron and 3 paired electron and our 3 bonding electron here. So the phosphorus, we have, this is the lone pair of phosphorus, and we have 3 single dot electrons that are shared with each bromine. This is the lowest dot symbol of bromine and phosphorus atom. Identify the type, or identify the column, to what columns that each one belong. As we know, identify, we need explanation. Column represent the number of valence electrons that represented by lowest dot symbol. The valence electrons are represented in the lowest dot symbol. The electrons represented in lowest dot symbol, they represent the valence electron. Hydrolyl electrons on the phosphorus or in the bromine lowest dot symbol represent the number of valence electrons in the atom that represented by the lowest dot symbol. So bromine Br exists in column 17. We have 7 valence electrons. P phosphorus, he will column 15. Since we have 5 valence electrons in the lowest dot symbol. Write the electron configuration for the phosphorus atom. On phosphorus atom, we must have, there is a missing information. The phosphorus atom exists in row 3. Since we have row 3 means that we have 3 energy level. We have K, L, and M. We have 5 valence electrons. At the outer energy level, we have 5 electrons. The previous energy level must be saturated. K level is saturated by 2, and level L is saturated by 8 electrons. This is the first part of first 3 exercises about the chemical bond.